Okay. I hope you like the previous presentation because it is more or less going to be somewhat similar within the examples mainly. So, hi everyone, I'm Bence Csati, and I'm here to talk about Kubernetes logging and how we modernize the logging operator. A few things about myself. I'm a software engineer at Oxoflow, where we are solving all problems related to observability and security. I'm a maintainer of two CNCF sandbox projects, namely Bankvault and the logging operator, which we're going to talk about today. So let's see what we have out of the box when we install Kubernetes. So what happens to your logs is basically the container runtime redirects the standard out and standard error of the containers, the logs of the containers to a file on the node, and when you call kubectl logs on a container of a pod, the kube client reaches out to the Kubernetes API, which forwards the call to the kubelet, which runs on the same node as the pod you would like to tail, and it reads the appropriate file. And that's basically it, what you get for the logging architecture of Kubernetes. There are a few minor things you can tweak, mainly in the kubelet, but you should only do this with caution. Mainly some log rotation and log location options. And when you're reading through the architectural documentations or the logging architectural documentation of Kubernetes, eventually you will stumble upon a line that says Kubernetes does not provide a native solution for cluster-level logging. And this is one of the main reasons why logging operator came to life. And obviously, it is a Kubernetes operator, which you can use the following way. You define a logging custom resource, which mainly configures the log aggregator of your choice. Right now, we support Fluentd and OXO-syslog. OXO-syslog being a syslog ng fork that we created and packed it ready for the cloud and for Kubernetes. Besides that, there are also a couple of settings for global flow control, namespace watching, and configuration management that you can also specify within the logging resource. Next up, you need something to collect logs for you, and that would be Fluentbit, which you can define in the Fluentbit agent custom resource. Fluentbit is deployed as a daemon set, meaning that it will be present on every node of the cluster. And when you have logs collected and routed by default to Fluentd, you need something to route the logs to your outputs of choice. So those are the finest things you need. Flows are beings that can match and/or filter on collected logs, and they are routing those logs on matched logs to your specified outputs. There are special cases for flows and outputs, namely you have cluster flows that can collect from all namespaces by default, and cluster outputs are available from all flows and all cluster flows. Let's leap forward to a hot topic today, multi-tenancy. But before we take that jump, a bit of history mainly about the logging operator. It was implemented around 2018 during the early evolution of Kubernetes around 1.10, 1.11 patches, when operators were just emerging as an extension pattern. At that time, the ecosystem prioritized stability and functionality over the multi-tenancy considerations. And the logging operator, initially focused on solving the problem of the cluster-wide logging without the tenant isolation capabilities. But later, as enterprise Kubernetes requirements matured, we had to do something and implement a solution for this too. But what does multi-tenancy actually mean? There is not a single good definition for a tenant, but rather the definition varies depending on whether we are talking about soft or hard multi-tenancy. Soft multi-tenancy often relies on namespace isolation, RBAC, network policies, and resource quotas. Obviously, it provides a lower overhead but less secure. It is suitable for teams within the same organization, but there are other use cases of using and implementing a soft multi-tenancy in an infrastructure. Hard multi-tenancy, on the other hand, implements strong isolation starting on the node level, but it can even reach heights by utilizing separate clusters. It is mostly required for multi-customer scenarios with strict security requirements. It adds a higher overhead of resources required, but provides stronger security. in many cases, the same organization may use both definitions of a tenant in different contexts. So there are several ways to build and design a multi-tenant solution for Kubernetes, each coming with its own set of challenges that impact the isolation level and operational complexity. So the team sits together and we try to implement multi-tenancy into the pre-existing architecture of the logging operator. And we came up with something like this. The idea was that each tenant should be powered by a logging resource, and the whole observability stack should be led by, or usually it's led by, an operations or infrastructure team, meaning they control the Fluentbit agents and the logging resources themselves. Of course, they have to cooperate with tenant users themselves so they can create the most appropriate logging resource for that tenant. And what tenant users actually manage is their own flows, and they can decide on their own outputs. And optionally, and we highly suggest that operations should have their own aggregator for security and monitoring purposes. Let's see our first demo. I have a couple of those. All right. I have a handy pre-installed script here. I hope you can see it, but I would try to zoom. Oh, that was too much. Yeah, it's good. So we created 2 clusters here, installed the logging operator with a Helm chart. We set some flags needed for later demo scenarios. We installed Loki. Customers are going to be used so we can demonstrate how multi-tenancy works. We also install Grafana so we can check on logs. And to mimic some log flow, we are going to use a log generator that we previously implemented. The resources that are getting applied, we have a customer BA namespace here. It's mainly here because you don't have to sit through while Kubernetes provisions Grafana and the Loki instances. So the namespace is ready for them. So we have customer A. They have an infra namespace which sits here in this control namespace field, which basically determines where Fluentd and other related resources managed by this logging resource getting deployed. We have watch namespaces here, which is matching on namespace labels here that logs are going to be collected for this logging resource in that namespace. This root config, we are going to worry about this in the final demo scenario. We have flows. We have one singular flow here, actually, that have some parsing and tag normalizing going on here. We don't worry about those. We are only caring about this right here, right now. We are going to match on logs that are coming from the log generator instance that was deployed in this customer A namespace, and we are going to route them to our Loki instance. The same is going on with infra. Main differences are that they are using cluster flows and cluster outputs instead. They have the configuration of a Fluentbit agent, as was discussed before, and also we have a logging route, and this is our decided way to decide what are tenants within the cluster. And how it works is really simple. So you have this source here, which the value right now is infra. This corresponds to this logging graph of choice. Logging graphs are a way of telling that which resource belongs to which logging custom resource, actually. And we are going to match on labels that are present on the logging resources. So we are going to route logs from this Fluentbit agent to every logging resource that has a tenant label. And right now we have a tenant label on this infra resource and on this one here. And if you just check into the cluster, what's happening right now, we have a log generator here ready that is generating Nginx access logs for us. And besides that, we have the Fluentds here. We can see some log flow going on here also. And the same is going on for infra. Basically, these are the 2 tenants that we have right now. And also we have Fluentbit here that is doing its work. If you just check on the UI, this is customer A's Grafana instance. If you just turn this on live, we can see that logs are being forwarded according to the output spec that was declared. If we check the one singular log message, for instance, you can see some information here that this log is coming from customer A, so on and so forth. Another interesting thing we can check, if we just take a look inside the infra Grafana instance, and if we just trust the autocomplete here, we see that there are two autocompletes here, infra and customer A. If you just search for infra type of logs, we can see that also we have infra logs flowing in with the same matter, like we have the tenant labels here, and so on. So yeah, that's basically what was our first attempt on implementing a multi-tenancy feature into the logging operator. This solution came with some caveats we identified. So up until now, our FluentBit agent had to handle a single aggregator destination, but now it is capable of routing on a whole another level, on the collectors level. And if the FluentBit agent is not configured correctly, or you are having misbehaving outputs that are affecting the others, for instance, in availability or performance, we are going to discuss this in the next slides. Because you can use, for instance, a disk buffer, and in theory, what could happen that you can take down the whole collection because of these buffers, because the file system can fill up if an output is becoming unavailable. That's corresponding to the second caveat I listed here, noisy neighbors, because in FluentBit, it is possible to set a global upper buffer limit, but there is also one per output. If a noisy neighbor, which is a term we use for overactive members of a tenant, is consuming almost all of its available memory, the log collection could stall, or worse, we could lose logs. If you imagine a scenario when you have two outputs and one of them starts failing, the collector immediately starts buffering the logs of the failing output. And once the disk fills up, the collector starts to fail, and Kubernetes will start to try to restart it, but it won't happen because the disk is filled up. So until you allocate some more, it will constantly be in a failing state, and the second output will suffer the consequences of that. We often refer to this as back pressure. And the third caveat I listed here is that the collector, which processes all the logs on the nodes, now has the ability to filter and route logs, but only a very limited set of attributes, logging domains and namespaces mainly. This is somewhat positive, on the other hand, because there are less space for errors. So yeah, this implementation was not flawless, and although many logging operator users liked it, we were not entirely satisfied with it. And we knew that an OpenTelemetry-based solution would be better. Besides, it was on the table long ago, and we had some requirements for ourselves that we wanted to be integrated into the logging operator later on. We want to make it crazy simple and and users to have a good experience using it. And so we started doing some proof of concepts and research work, and we quickly realized that these are distinct tools for distinct purposes. The first problem we identified was the architectural mismatch between the logging operator and OpenTelemetry, because the logging operator was created specifically for cluster-wide logging in the first place, with a focus on collecting, processing, and forwarding log data, so having this centralized log management ready. And OpenTelemetry, however, on the other hand, is a comprehensive observability framework that handles not just logs, but traces, metrics, and profiles through a completely different architecture and uses different data models. The second problem we identified and we were aware of, that we knew of a couple of users of ours, users and organizations that have invested heavily in building and implementing, maintaining the logging operator based on its original architecture. And many of them have built operational processes, monitoring systems, compliance frameworks around its specific capabilities. So if you would happen to introduce an OpenTelemetry-based solution, this would disrupt these existing setups, potentially breaking backwards compatibility and requiring those existing users to adjust to these. And the third fold is obviously complexity. So if you would happen to force OpenTelemetry into the pre-existing architecture of the logging operator, we would create somewhat of a hybrid solution that serves neither purpose as well. So also, the logging operator's existing patterns for configuration, deployment, etc., would need significant restructuring to accommodate OpenTelemetry's concepts. So we decided that somewhat of a better solution would be to develop a separate operator that we design specifically around OpenTelemetry's concepts and architecture, while maintaining the logging operator for environments that need its specialized capabilities for cluster-wide logging. And so we created it, and we like to tag it as an opinionated, convenient, robust API with multi-tenancy out of the box that can turn telemetry event streams, logs, metrics, traces into Kubernetes resources. It provides an isolation and access control for telemetry data, similar to what you have with Kubernetes pods, secrets, and other resources. I listed hard to break design there, but this is because of a huge reason of ours that the operator creates the OpenTelemetry collector configuration entirely within its inside functioning, meaning that if we only take the minimum amount of input required to create that configuration from users, and if that config turns out to be invalid, the operator is aware of it all the time, and instead of just deploying an instantly failing resource, we are just notifying the user. So yeah, big upside. And also, when it comes to the OpenTelemetry configuration, if you happen to wrote one of yourself, and if you would happen to install it into a fresh infrastructure, you would have to face several challenges to write that configuration for yourself, because it can quickly get out of hand if you have many outputs and many receivers and so on. But this operator should take the burden off of your shoulders. But yeah, and a big plus for us was that we have no more of that buffering problem we had before, because in OpenTelemetry you have distinct buffers per pipelines, and you don't have a specific global upper buffer limit. So our only obstacle would be that allocated disk space we had before. Yeah. And last but not least, it was designed, obviously, so it can integrate with the logging operator. Yeah, second demo scenario. I have another setup script here, ready to go. In this one, this is going to be a very simple, very quick demonstration of the telemetry controller, just to get the taste of it. We are going to go into the second cluster we created, installing telemetry controller and applying these two manifests. So these are the resources required for the telemetry controller. We have the collector instance, same control namespace that we had with the logging operator. So the OpenTelemetry collector will be deployed in this namespace. We have tenant selectors, because you might have a scenario where you want to use more collectors and you want to specify which tenant should be managed by which collector. And these are matching all labels that are present on tenants. Tenants are beings that are defining your tenants, obviously. They have two main configuration fields in the spec. Log source being the one that defines from which namespace logs should be collected. We are going to see how that works in action. And also subscriptions are another abstraction layer above tenants, because you might have a team that are using a tenant, but only interested in a subset of the logs. So instead, you can just create different subscriptions, and the subscriptions are beings that has this OTTL condition here that must be evaluated to true, so the log can flow through. For the sake of simplicity, this is just letting through all logs here. And subscriptions have somewhat similar to flows, can define the outputs they want to route the logs at. And for outputs, we are just going to use another collector that will receive these logs. And yeah, the configuration of that is here. It's quite simple, using OTLP, gRPC for receiving, and just exporting to the standard out, so you can see how this works. All right, switching context. Yeah, so we have the same log generator here creating the Nginx access logs, and this collector is collecting all the logs for us, if you can see it. And one interesting thing here I would like to show you is that we are using the file log receivers from OpenTelemetry contrib. which basically works the following way. That if you remember one of my first slides, I said that I showed you that Kubernetes persists all log files on the nodes file system. And yeah, this is what actually happens. So you have these warlock pods, name of the namespace, name of the pod, pod UID, and finally the container and the log itself. And also there is the receiver collector here, which is receiving all the logs that was generated by the log generator. You can see some information that from which tenant this log is coming from, the subscription that delivered, and the exporter here. We are using the KAS custom processor here, so we can add some more resource attributes here, and the same goes for our first tenant. And another interesting thing, I have a alias here that can show us what the configuration looks like for OpenTelemetry that was created entirely by the operator. So I'm not going to go through this entirely, but yeah, here you go. It's quite long. Yeah. Let's continue. So, and yeah, connecting the dots. Not long ago, some of our users, when they started using the logging operators solution for multi-tenancy, they started reporting issues with that buffering problem that I also mentioned in the caveats. And meanwhile, OpenTelemetry remained the elephant in the room we didn't want to ignore anymore. So with our maturing telemetry controller, the timing was perfect, so we could evolve logging operator and get rid of Fluentbit altogether and turn for using OpenTelemetry collectors instead. And the outcome was awesome, and there was just a very limited things we needed to add. So since it was one of the most important things for us that we didn't want to disrupt existing user flows, we hid this feature behind two flags, simple and easy. One to decide between whether you want to use the Fluentbit type of routing or the OpenTelemetry-based routing. You have two flags for that because of a number of reasons. First, if you don't trust the solution, you can just, for testing purposes, you can switch all those flags. One of them is disable and one of them is enable. Actually, you will see that. So if you just turn them on, you are using basically Fluentbit and OpenTelemetry at the same time, so you can see if that works properly and everything is going as expected. So, and if you like the solution, you just turn off Fluentbit and you can just go on with using OpenTelemetry. And also, besides adding these two flags, a new controller was needed to be written for the logging operator. And it was just a couple of hundred lines of code, mainly boilerplate, but it actually is not so long. You can check it out if you want. And what we avoided was major, and yeah, so we didn't break existing workflows while we introduced somewhat of a multi-purpose architecture. We avoided this massive refactoring that I was referring to many times, and also the technical debt that would have to be created if we would happen to accommodate OpenTelemetry. And obviously, the number one priority we had that we don't want user confusion by adding these fundamentally different architectures together. Right, final demo. Right. So in here, we are going to switch back to our original cluster. We are going to apply the B customer and going to update infra here. So it is going to use the OpenTelemetry-based routing instead of Fluentbit. This delete is here because there is a config reload mechanism implemented in the logging operator when it deploys Fluentd, so it can reload the configuration when the secret changes or anything happens to the configuration, but that only kicks in once in a while. So this is faster. Also, we are going to deploy another log generator for our final tenant here. This is similar to the first tenant that we created on the first scenario. The main difference is here that we can now work with this root configuration. We have these two flags here. One is enable, one is disable. it should be 2 disables or 2 enables, but there you have it. Also, you have tenant labels that these are going to be put on the created tenant resources that is going to be created by the controller. So these can match up with the collector that you also have to deploy. Yeah, everything else is the same. But another interesting thing is here. So this is the collector resource for telemetry controller. This is the only thing that your operations or infrastructure team has to deploy. And yeah, as I mentioned, we are turning on the routing for OpenTelemetry for the infra 1, 2. Yeah, and this finished. If we check into the cluster, switch context. If we check into the cluster now, we can see that we already have this OpenTelemetry collector deployed, and everything is kicking in. The file log receiver started catching up on the collected logs. We have this handy command for kubectl that displays all the tenants and all the telemetry controller based resources that you currently have, so you can check on log sources and so on. And yeah, if we now check on the Grafana instance for infra, and if we search on namespace infra, for instance, obviously, we can see now some hints in the logs that it indeed switched on the flag. So we are now running absolutely on OpenTelemetry collectors, which is hinted in here because we are using a Fluent forward exporter, for instance, that is exporting logs from OpenTelemetry collector through our Fluentd instance. And also these tenant and subscription labels are also hinting that, yeah, we are completely running on OpenTelemetry now. But if you remember, customer A is still running on Fluentbit. But let's say we are satisfied with the solution, we are ready to adopt it finally, and you are finally ready to get rid of Fluentbit altogether and start using OpenTelemetry collectors with the logging operator. And right now we are doing just that. So right here we just flipped on these flags. We are now going to run on OpenTelemetry collectors, and we are going to get rid of Fluentbit agent and the logging routes altogether. And yeah, what happens is expectable. If we get the secret here. And just search on the logs, we can see that customer B, I changed it on customer A, sorry. Yeah, so if we check now, customer A, which was previously running on Fluentbit, now runs on OpenTelemetry collectors. In just a matter of seconds, it just turns on, and yeah, there you have it. Yeah, and that's basically it. One of the key takeaways I listed in here for me that I think it does not work to modernize your solution while breaking some existing patterns and requiring your existing users to adjust to a new solution that you think is better, but it is going to take them some time to adjust to those. So yeah, thank you. You can find my socials there if you're interested. And you have some QR codes here if you would like to check out the telemetry controller logging operator, you would like to try the demo scenarios for yourself, you can do that here. Wow. Are we going for the questions?
Okay, thank you. If you want, you can read the questions and then answer them accordingly.
So the first question is, why use Fluentbit for this operator in general in 2025? Vector exists and it is great for logs delivery. Yeah, it's a hard one. Fluentbit is getting, for the first part, Fluentbit is actually getting a lack of maintenance lately, as we been observing it. And that was one of the main reasons we wanted to switch for OpenTelemetry in the first place. And we wanted to create a solution for that too. And why use the operator altogether? That hurts a bit. So the logging operator solved many problems before, but obviously there have been some modern tools that came out lately. But yeah, there are people currently thanks. So we are currently aware of a number of users that are still using the logging operator, and we are still maintaining it. The project itself is the biggest strongness, I think, for the logging operator is that if you want a great solution out of the box that is very flexible and it already supports a bunch of outputs out of the box, and it supports many good solutions for routing logs from your aggregator, and you have many options that you can define and use for parsing and filtering that are still old but gold. So yeah, that's basically my answer for that. Can you share YAMLs, configs, and scripts? They are hard to read. Yeah, there is the demo repo there, so you can try it. Yeah. Can we migrate from Filebeat-based log collection with Kafka output and keep rest of the log processing and enrichment pipeline, Kafka logstash ES? I think yes. Well, from the top of my head, I can say for sure you have to try it. but those are tools that are and solutions that, yeah, we definitely support those, and you should absolutely give it a try. And this next question is, would it be a good solution for Kubernetes events for a namespace for longer duration events that 1 hour instead of something like event router? I have to think about that. I don't have a great answer for that, actually. Event routing is I think it's not hard nowadays. Within the logging operator, we use a very old that is the next problem on our list, on our roadmap, that we are going to tackle mainly because we are not satisfied with the old event router solution that we have there. But yeah, that's all I can say about that. I don't have a great answer for that. And yeah, for events, you can try that. All right. Thank you.